Hello, I'm Vivian Chan. In this video, I'm going to explain 2018 HSC Maths Extension 1 question number 10. It is about simple harmonic motion. There is a particle moving in simple harmonic motion, and x is the displacement of the particle, while v is the velocity of the particle, and the equation, the velocity displacement equation, is this one, where n and k are constants. Initially, the particle is at x equal to k. Based on all the information provided, the question asks for a displacement time function. So we have to know what is a simple harmonic motion. Simple harmonic motion is talking a particle moving or oscillating continuously within a certain range. This is the center of the displacement. These are the two far endpoints, furthest to the left from the center and furthest to the right from the center. At the two endpoints, the velocity here equals to 0. Because as you can see, all the particles has to change direction. If it's moving to the left-hand side, up to here, it has to stop. The velocity has to become 0 and then change direction, coming back to the center. And here all the way to the right. And at this point, the particle stops and then change direction, come back to the center. So the velocities at the two far endpoints should be equals to 0. Now, let's look at the velocity displacement equation provided by the question. When velocity equal to 0, so v equal to 0, let's factorize this equation, take out the common factor of x. We have n squared times x times 2k minus x. N is the number of oscillation. It cannot be equal to 0. Therefore, we can only have either x equal to 0 or 2k minus x equal to 0, means x equals to 2k, which means the displacement should be from 0 to 2k, which means the displacement of particle should be from the origin, from x equal to 0, all the way to 2k, and the center is k. The question tells you that the particle is initially at x equal to k. That means at the very beginning, when t equal to 0, the particle should start from here at the center. And now let's take a look at the sine and cosine curve. Both sine and cosine curve, they are oscillating curve. Sine starts from center. When t equal to 0, it starts from center all the way to one end, comes back to the center, all the way to the other end, and repeat itself as time goes by. For cosine curve, it starts from far end, going back to the center, and then all the way to the other end, coming back to the center, and oscillating in this manner. Now, this one, the particle starts from the center when t equal to 0. It must be a sine oscillation, start from center to one far end, coming back to the other end, coming back to the center, instead of start from one far end, coming back to the center, going to the other end, coming back to the center. This is the cosine. Cosine is not what we need in this simple harmonic motion. Therefore, you can cross out all the cosine displacement in terms of cosine function, which we only have b and d left. Let's then now take a look at the two extreme points, two far ends. This, when sine equals to 1, it should represent here, means particles should be at 2k displacement, right? When sine equal to 1, k plus k, the displacement equals to 2k. But for option D, when sine equal to 1, it should be 2k plus k, the displacement according to this displacement function, the particle, when sign equal to 1, it should be at 3k instead of 2k. So our displacement time function here should be option B. But we can still double check it with the other end. Okay, when displacement equal to 2k, it refers to the equation in option B. How about when the displacement is at the origin? It means the particle is here when sign equals to -1. Means minus k plus k equal to 0, displacement equal to 0, is satisfied with our condition in this question. But for option D, when sign equal to -1, it's minus 2k plus k. The displacement of this displacement time function should be located at minus k instead of 0 origin, which again confirms your D is not your answer.